So now we're going to get into a discussion of another type of substance known as compounds, right? So if you recall, we said that elements are substances which cannot be broken down into simpler substances using chemical means. Well, compounds are basically different in that compounds can be broken down into simpler substances by chemical means, right? And that is true for most substances. So the vast majority of substances that exist on Earth or in the universe, I would say, would fall into the category of compounds, all right? An example of a compound would be water, right? Right? Water is made up of two elements, hydrogen and oxygen, and you can break down water into hydrogen and oxygen. You can pass an electric current through it via electrolysis, and you can get the two elements that make up water. Another example is sodium chloride, which is table salt, right? Table salt, again, you can pass an electric current through it if it is melted, and you're going to end up with sodium and chlorine, all right? So these are just two of the many examples one can point to of compounds, all right? Now, one thing about compounds that you need to be aware of is that their composition is always fixed. Now, this here is a law which basically states that whenever you have a compound made up of two or more elements, the amounts in terms of their proportions by mass is basically fixed, all right? That is true for every compound. The proportion of the different elements that make up the compound would be constant. So just to give an example, let's look at water. There are two elements that make up water, as we said before. One is hydrogen and one is oxygen. And if you were to look at the actual percentages by mass of each element present in water, you'll see that 11.2% of it would be hydrogen, and the rest, which is 88.8%, will be oxygen, right? So every single sample of water that you may obtain, it doesn't matter where you get it from. If you get it from outer space, or if you get it from rivers, seas, from your tap, from rain, it doesn't matter. The percentages of oxygen to hydrogen will be fixed, right? And as stated here, if you have a substance which contains hydrogen and oxygen and the percentages are not as shown here, then that compound would not be water, it would be something else, all right? And that is true for every single compound. Their percentages will be fixed. That's just basically how compounds are. Now, here we have another example, another compound which contains hydrogen and oxygen, but this time it's hydrogen peroxide, right? So as it's stated here, hydrogen peroxide always contains the same two elements, right? Hydrogen and oxygen. Now, if you take the percentage of hydrogen in hydrogen peroxide, it's 5.9%, and the percentage of oxygen in hydrogen peroxide is 94.1%, right? And again, these percentages are fixed, right? If you have a substance which contains hydrogen and oxygen and their percentages are different, then you know that you're not dealing with hydrogen peroxide, you're dealing with another substance, all right? So that's basically what is characteristic of compounds, the proportions of the different elements that make up that particular compound is always going to be constant. Okay, one final thing I want to talk about in this chapter is the fact that we can also have substances that exist in nature which exist as a mixture as opposed to a pure substance. So when we were talking about pure substances, we were talking about compounds and elements. But a mixture is different. A mixture is, as you can see here, a physical combination of two or more substances. And the thing about mixtures is that your components can exist in combination in variable amounts, right? So you could have a 50-50 mixture of two substances, or you can have a 75 to 25%, and so on and so forth. So in other words, there's literally an infinite number of possibilities in terms of the combinations and their proportions when you're mixing two or more substances with each other. Now, there are two types of mixtures that we're going to talk about here. The first type is homogeneous, and the second type is heterogeneous mixtures, right? So let's talk about a homogeneous mixture firstly. A homogeneous mixture is a uniform physical combination of two or more substance. And as such, it has one phase, right? So an example of a homogeneous mixture, and by the way, another term for homogeneous mixture is solution, right? So you can use the term solution or homogeneous mixture interchangeably, right? So one example of a solution or homogeneous mixture is a solution of sugar mixed with water, right? So if you add sugar to water and mix it thoroughly such that the sugar dissolves, then basically you're going to end up with a uniform homogeneous mixture, right? Because after mixing, the sugar will be evenly dispersed through the volume of the water such that you will not be able to detect the difference between the sugar and the water, right? And I'm quite sure you can name some other examples of solutions or homogeneous mixtures from your everyday experience, all right? Okay, so that's homogeneous mixture. Then heterogeneous mixtures are mixtures that are non-uniform combination of two or more substances, right? So if you mix, for example, sugar and fine white sand, basically what you'll find is that it's not uniform, right? You can actually make a distinction between the sugar and the sand. Another example would be oil and water, right? If you add oil to water, eventually what's going to, well, not eventually, immediately what's going to happen is that you're going to have a separation into two layers where the oil will be at the top and the water will be at the bottom, and there's a distinct boundary between the two, right? So those are just two of many examples that you can name of heterogeneous mixtures, right? So pretty much all mixtures can fall under the category of heterogeneous or homogeneous mixtures, all right? So to summarize what we talked about in terms of matter, basically matter can be placed into two categories. You can have pure substances and mixtures, all right? And we talked about pure substances. There are two subcategories under pure substances. We have elements, which remember are substances that cannot be broken down into simpler substances by chemical means, and compounds, which are substances that can be broken down into simpler substances by chemical means, right? And then over here, as far as mixtures are concerned, there are two categories or subcategories. You have solutions or homogeneous mixtures, where basically you have one phase where you have two or more substances combined with each other physically. And then over here, heterogeneous mixtures, where the components of the mixture can be distinctly observed, all right? They won't be uniformly mixed. Okay, so that's basically a summary of what we talked about today. So in class, we're going to look at some questions dealing with these topics. And of course, if you have any questions you want to ask, please bring those questions to class and we'll discuss it, all right? Okay, so that's it for this chapter. And we'll get to chapter 3 next week. All right, take care.